This is for Year 11 methods. It's displacement time graphs, question number 4. A particle moves along a horizontal straight line. So, my particle is going to move along a straight line. Might go forwards, might go backwards. Okay, so I know that it travels for more than 5 seconds. It starts at s equals 0 and it travels more than 6 meters and then comes back down again, and after 5 seconds it's back at the start and continues. So it starts here, it goes really fast and then slows down, then stops, comes back and continues in that direction. So it went up here and back again after 5 seconds and then continues into the negative, which is lights down there. So this particular particle is doing this. So instantaneous velocity is 0. Instantaneous velocity is the gradient at a particular point, and I can draw a tangent to work out what the gradient is. So I'm thinking my gradient is very steep and positive, very steep and positive, very less steep. That's where it's going to be 0, then negative, negative, negative. So my prediction would be maybe at 2.5, assuming that this looks like it's a parabola and perfectly symmetrical. So I'd be thinking at what time is instantaneous velocity 0? At t equals 2.5 seconds. For what values at t is the instantaneous velocity positive? Well, my tangent would have positive gradients all the way along here. So I think that t would have to be from 0 to 2.5. Not inclusive of 2.5 and also not inclusive of the endpoint, but we'll worry about that later in the chapter. So here's the point where the gradient has a positive value, therefore the instantaneous would be positive. How far from 0 does the particle go to the right? Well, it looks as if it's a little bit higher than 6. So I'm saying probably 6 point, it's a bit hard to tell on this scale, let's say it's 6.2 meters. How long does it take to return to 0? Well, it's going to be back again, turn to 0 then, which will be at 5 seconds. And estimate the instantaneous velocity of the particle at t equals 1. Okay, so I need to draw a tangent. I might just clean up my screen. Okay, so 1 is around about there. So I need to attach a tangent at that point. That's pretty good. Okay, I'm going to use that as my tangent that I'm attaching at x equals 1. What I would now like to do is to find some coordinates. So, reading along the line, I'm thinking that here it is at 0 and 1, and here I'm at 1 and 4. Therefore, 4 minus 1 over 1 minus 0, 3 meters per second is going to be my instantaneous velocity at t equals 1.